Okay, what we're going to do over the next series of vodcasts is take a look at bonding. We're going to try to explain why atoms come together to form compounds and what that means with how they react with other compounds. We're going to talk about different types of bonds. We're going to talk about bonds within a molecule, and then we're going to talk about bonds between molecules. Okay, so let's get started and just talk about in general what is a chemical bond. Okay, so what we want to do is first of all describe what is a chemical bond. And it really is fairly simple. A chemical bond is when two or more atoms come together to form what we're going to refer to as a compound. So for example, you've got a carbon atom and you've got an oxygen atom. They come together and they can form carbon monoxide. If you had another oxygen atom, you could form carbon dioxide. So anyway, the bond then is that force that holds the group of atoms together, and they make the two things, or more than two things, act as a unit. In other words, this individual carbon and this individual oxygen now come together to form this thing, which acts as its own entity, with its own properties and own reactivity. The reason these things will bond together, and this is very important, and we'll talk about this throughout the year and throughout this course, two atoms will bond together if their energies together are lower than the energies separately. So for example, if you've got two hydrogen atoms, they each have a certain amount of energy, and we'll talk about what that means when we talk about the energy unit, but let's just assume they have a certain amount of energy. And let's just say that energy is 5 for each of these. And that doesn't really mean anything, but don't worry about that. So let's say separately these things have an energy of 5. When they come together and form a compound, their total energy might be 8. So in other words, together these things have an overall energy that's lower than when they're apart. That's why compounds want to come together to make bonds. So then let's take a look at these two hydrogen atoms graphically. You've got your one hydrogen atom here and your one hydrogen atom here. What you can do is bring those together, and as they come together, their energy starts to get lower until they form a molecule. So over here, this is represented right here. You can see your x-axis is the distance between the molecules. So way out here, when that distance between that atom and that atom is great, their energy, we're going to say overall, is 0. So we have energy on the y-axis and the distance between the atoms on the x-axis. So as that distance gets closer and closer, what you see is their energy starts to drop till they form a molecule. So way down here, when these two hydrogens come together and share those electrons to form a bond, the energy drops significantly compared to what they are separately. Now if you were to keep decreasing that distance, in other words, you were trying to shove those hydrogen atoms right up against each other and really try to get them closer and closer, you can see the energy goes way up. And that's the process that we'll talk about later that we refer to as fusion. When you put those two hydrogens together, they'll form a helium and release a tremendous amount of energy. But we'll get to that a little bit later. Alright, we're going to talk about two general types of bonds, and there are other categories of bonds, and there's some other subcategories of these two types, but in general we'll talk about ionic bonds and covalent bonds. And it's important to understand these two types of bonds are what we refer to as intramolecular forces. It's intramolecular forces. In other words, we're talking about the bonds within the molecule itself. With an ionic bond, what you have is a transfer of electrons, and that's the symbol that we use for electrons. So essentially what you'll have is, say, a sodium atom with a positive charge and a chlorine atom with a negative charge. The sodium atom will give up an electron to get that positive charge, and the chlorine atom is going to take that electron to become a negative charge. These two charges are opposite, so they attract, so those two things will form an ionic bond. In other words, it's that opposite charge that brings them together to form what we call an ionic bond. And we'll talk about how all this happens in a vodcast coming up. So an ionic bond is a transfer of electrons, and the two atoms are held together by opposite charges. Covalent bonds, on the other hand, are held together by a sharing of electrons. In other words, that, let's say we'll take that carbon and oxygen. What they'll do is share a couple pairs of electrons, and that's what those lines represent. And that sharing of those electrons is what holds those two atoms together. And again, we'll talk about this in much more detail and how this happens. So ionic bonding is a transfer of electrons. The two atoms are held together by opposite charges. Covalent bonds are when two or more atoms share electrons, and it's that sharing that holds them together. To explain how all of that takes place, we need to investigate what we refer to as electronegativity. If you remember back a unit, we talked about the trend on the periodic table for electronegativity. And what we're going to do is use that trend now to start talking about bonding. So let's just review what electronegativity is. First of all, it's the ability of an atom in a compound to attract shared electrons towards itself. So for example, if you have hydrogen and fluorine, and they're going to share a pair of electrons, one of these atoms, the one with the higher electronegativity, has the ability to pull the electrons towards it. So in that bond, fluorine is going to have the higher electronegativity, so the electrons go closer to the fluorine atom than they do the hydrogen atom. And what that's going to do is it's going to give that fluorine a partial negative charge, and that's the symbol we use, and it's going to give that hydrogen a partial positive charge. And again, we'll talk about that in much more detail also. So electronegativity is that ability of an atom to attract electrons towards it in a compound. Trend on the periodic table of electronegativity is increasing, going left to right. So as you can see, fluorine has a higher electronegativity than, say, lithium, and it goes in that direction, 1, 1.5, 2, 2.5, etc. And it decreases going down the periodic table. So the one with the smallest electronegativity will be francium. The one with the highest electronegativity will be fluorine. And you should be able to tell me what the relative differences in electronegativity are. And if I ask you what has a higher electronegativity, calcium or bromine, just because of their placement on the periodic table, you should know that bromine has a higher electronegativity. It's further to the right. Since the trend is increasing, bromine has a higher electronegativity than calcium. So you should be able to tell which atom has a greater electronegativity just by looking at the periodic table. Then what we're going to do is look at differences in electronegativity. So as you saw from the previous slide, you can see that each atom has its own precise value for electronegativity. If you know the two atoms that you're talking about, the difference in those electronegativities will give you a certain value. And what we're going to talk about is 0 to 1.9. In other words, if you take the two electronegativity values, subtract them, if your answer is from 0 to 1.9, we're going to call that a covalent bond. If it's greater than 1.9, we're going to call it an ionic bond. And it can go up to 4 because that's the electronegativity of fluorine. So when you're looking at the atoms on the periodic table and you're trying to determine what type of bond it is, take their electronegativities, subtract them. If the answer is between 0 and 1.9, it's what we're going to call a covalent bond, and we'll talk about covalent and polar covalent. If it's greater than 1.9, it's ionic. Okay, what we're going to do then is use these concepts to look at bonding in more detail.